Okay, guys, now let's look at the simple hydraulic system. So, on a simple hydraulic system, we'll be looking at four things. We have the actuation cylinder, we also have the pressure intensifier, we also have the pressure accumulator, and a simple um, and which is what you call a hydraulic press, a simple hydraulic press. So first thing first, we will check the actuation cylinder. So on the actuation cylinder, we have a single acting cylinder. So here on an actuation cylinder, we have something like this. The same we have here. Let's say we okay. So let's say we have this piston this side applying this force. So if the piston applied this force here in the cylinder, and then we only have the fluid that is coming in here, going up and down for this cylinder. So this is called a single acting. So we have a single acting actuation cylinder, and then we have also a double acting. So on a double acting, now we have something like this. Let's say we have a cylinder opening here, and then we also have another opening this side. Yeah, and then we have piston inside. Okay, yeah, it's something like this. So on a double acting now a cylinder, we have the fluid that is coming in this here, and also that is coming in here. So that means a downward stroke is going to push this pressure. Let's say we have fluid inside. So when this piston is going down, is pushing out this pressure, and then this other one is pulling. So most of these cylinders, these double acting cylinders, is used on a pump. So on a pump is when you're pumping fluid, when you're using a reciprocating pump. A reciprocating pump means that the movement is down and up, or left and right. Yeah? So here, when this piston is moving down, it's going to push this fluid out, and then it causing an inlet this side. And then when it's moving out up again, it's causing a work. When the fluid is moving out, we say it's doing the work where it's going to be applied, right? So now on a single acting here, we always know that we have the formula for pressure, which is equal to force over our area. So that means the pressure that is developed here is going to depend on this force that is applied on the fluid, on the piston, and also the area. So the area here of the area of this piston, and then we also have volume. So the volume will be equals to which is pi d squared over 4 multiplied by l, which is going to be our stroke length. Now, so this stroke length now, so sometimes you find that your volume is written as volume is equals to area multiplied by length. It's because this one is a formula for it. It's formula for area. Always area is equals to pi d squared over 4 for a cylinder. So then this one is called a double. This one is a single acting actuator, and then this one also a single what, or this one is a double acting actuator. So this double acting actuator, this one, it has what you call, it has a single rod. this single rod, okay, single rod, which is this one. So that means here we have two types of we have two part. We're going to apply calculate the force that is when this one is going this sorry when this piston is going down, is causing what a certain force. We can call it a force number one. So this force number one, when it's going down, is it will what will be pressure equals to force number one over the area. So it's because now when we are on a double acting actuator, we also consider the the diameter of it of this piston. Now, the diameter of the piston rod. This one, let's say, small letter D. And then this side is the diameter of the piston. Let's make it a capital letter D. Now, so that means now your force will be force will be equals to force one will be the pressure multiplied by the area. So this area now is going to be this pi diameter over 4, so which is going to be this side. But then now when you calculate the pressure that will be developed, or the force that will be developed when now it's moving up now, so when it's now going this direction, now it's causing, let's say it will be causing a force number 2 now. So when it causes a force number 2 going this direction, therefore, now this piston now becomes what you call a a hollowed shaft. So that means we have a circle, which is what, which is this the circle of it is the diameter of the piston, like this. And then we also have what you call the diameter of it of the piston rod here. So now the area is no longer, the fluid is no longer holding the whole area, but then we have to subtract what the area of it of the piston rod. Now, so that means here, to get the pressure number one, you're going to say it, we're going to, oh, let's make it 1 here. So now it's going to be F2 would be equals to the pressure multiplied by area number 2. And then this area number 2 now is going to be equals to, we're going to say is pi into d squared minus small letter d over 4. So this is the diameter of the piston. Sorry, okay, it can be diameter of the piston, or it can be also the diameter of it, of the whole cylinder, subtracted by the diameter of it, the diameter of this uh, piston rod. Now, so therefore, now you're going to have what you're going to have two forces. So if they say calculate the difference in forces, then you know that the difference in these two forces should be F1 minus F number 2. This is going to be the difference of what, of these forces. And then again we have what you called a volumetric flow. Now, so a volumetric flow in our case is represented by this one, so which is going to be equals to a multiplied by velocity. Now, so the area multiplied by velocity, it gives us what you call our volumetric flow, and our volumetric flow is always in cubic meters per second. So this is what, this is our volumetric flow. But then we know that velocity is always displacement over what, over time. Now, so the displacement, now we talk about the displacement, the movement of what, of the piston from the top side to the bottom side. So when you are applying the force number 1 in this case, when it's moving down, the 4 is going to move a certain displacement. So the displacement, we are in this case we are talking about what, our stroke length. Now, so the stroke length now is becomes what, our displacement, and then the time that it will take this piston to reach the bottom side of what, of sorry, the time it will take the piston to reach what, the bottom side of the cylinder is what is going to be our T. So we can then say the volumetric flow is also, it can also be calculated by area multiplied by the stroke length. So our stroke length is represented by SL. Now that means it's the displacement of what, of the stroke, or it's the displacement of the what you call, of our piston, then divided by our time. So this will give us what, our volumetric flow. So if they say calculate the time it will take what, this piston to reach the bottom center of what, of the cylinder, then you know that you need to have what, your volumetric flow, your piston, your area, your stroke length, and then your time. Then you can get what, this volumetric flow. So, and then we also have we still on the actuator. So on the actuator we also have this one where we have these two cylinders like this. So this one is also a double acting, but then now this double acting, it has what you call double, this is our rod. Now this is our piston, and then it have a piston rod. So this is also a double acting. Now this is a double acting, but this double acting, it has now also has um double it has double what, double piston rod, So on this one, it's a double acting, but it has what, a single rod, which is this single rod. And then this one is a double acting, but it has what, both it has double rod again. So on this one is going to be the same unless the piston rod are not on this are not the same diameters. But if the piston rod are the same diameters, the then for your pressure will also be the same as what, volume for F divided by area. So that means the force that is going to be applied on the both side will be the same if what, if the diameters are the same. If the diameters are not the same, therefore the force are not going to be the same, because the areas will no longer be the same. But the area again here will be still on a hollowed shaft, which is going to be d squared minus d squared over 4. So it's going to be this diameter of what, of the shaft, sorry, of the rod, then, and the diameter of what, the diameter of the cylinder. So this is what, this is going to be your what you call, your single and for double acting and single acting. So now we also have the formula to calculate power, right? So power always equals to force multiplied by velocity in our case. Now, where we know that this formula for force multiplied by velocity, it's taken from what? It's taken from where they say power. We know that power, when we define power on science, we say the power is the rate of doing work, which is work done over time. And work done, we know that work done is what is force multiplied by displacement, therefore over time. So we then conclude that velocity displacement over time, it gives us what? Velocity. We then said we can also calculate power by saying force multiplied by velocity. We can get power. Or if you have the work done, it's what as this one. So if maybe they say calculate the work done by the piston, then you can get the work done here, right? And then also this one, you can calculate your power by saying this power will be equals to your force multiplied by the stroke length. Remember, your stroke length is what is your displacement over the time. Then you get what? You get your power. And then I think I have touched all the other things that you have to know on what on an actuator. So this is what this is our actuator. And then the other thing that I need to touch is what you call the pressure intensifier. So the pressure, okay, the pressure in intensifier, this one. So the pressure intensifier, this one is actually something like this. Sure. Okay, where we have a piston here, and we also have a piston here, and then this is a piston rod. Okay, so here say this is fluid, this is fluid. Okay, so this is an example of what you call of a pressure intensifier. No, pressure intensifier. We have also the diameter here. Okay, so here on a pressure test intensifier, this one is saying this is the we consider a simple industrial hydraulic system which consider the power of a pack supplier um, fluid under a pressure of 3 packs of machine. So that means on this one, when we wanted to change the fluid or the pressure on a machine, we use the pressure intensifier. So here, this one it can be installed in the Ford machine so that the fluid or the pressure it's kept constant. Now, sorry, the force that is acting here will be kept constant, right? So uh, this machine operates at a high pressure than other machines. So instead of installing a new power pack as well, so which is additional cost. So a pressure intensifier is installed, able the machine to operate on the existing what hydraulic system. So and then the pressure intensifier is also known as what as is also used to drop the system pressure by turning it around. So this is what this is the pressure intensifier, just a simple diagram of a pressure intensifier. So that means here, if you have a system that it's working, right? Let's say let's just remove this one, right? So if you have a system of maybe this is the piston. Now when this piston is operating here and there is a need of applying another cylinder or another what you call another system. So instead of making this system again, you just add another cylinder on top of what of your piston, so that when the piston is moving down, it causing a suction stroke on this side. When it's moving this side, it's causing pressure this side. Now so then more for when it goes this direction, it acting both side. So this is what is a pressure intensifier. So they use this one to eliminate, let's say you have a car. Then it's just a hypothetical thing. No? It's not like it's working in that way. So let's say you have a car, then you have both wheels of a car, and then you also want to install a braking system. Yeah, let's say this is the front system, and then you have your cylinder here. When you press your brake system, and then this car will hold these wheels here, so causing what this one to know. So instead of installing, now let's say you want to install another braking system on the back side of the car. Now, instead of applying a new system, right, that is going to work independently, you just add another cylinder here on what, on the existing what, on the existing cylinder, master cylinder, so that when you apply the brakes, this one will go both side. Now, so that's one, it's actually saying on what, on the pressure intensifier. So under pressure intensifier, we have to know that we here we have volume number one. We also have the diameter number one, where we can cause what, area number one, and then we have the pressure that is here now, and then we also have another here, same thing, but then now it's different. So it's volume number two, area number two. We also have pressure number two. Like area number two, you're going to have what, diameter number two. And then now for this pressure intensifier, we know that the force that is working here is the same. No, so that means when you say force, it's equals to pressure number one multiplied by area number one, is still the same as what, as pressure number two, area number two, right? So that means now you can also calculate what, area number one, by using this one. So that means the force are the same, right? And then this is actually it's a pressure intensifier. And then for the simple for the hydraulic press, we have done hydraulic press on N3 and N4. I won't touch hydraulic press here on N3. And then the accumulator is still the same as that one. So the accumulator is just that it store energy. Now let's say if the accumulator is something like this. So you have fluid, and then it has what, it has a valve here, a non-returning valve. So when you press, this fluid will go inside here, and then this valve will close. So it will store the fluid this side now. So it will preserve a fluid this side, and then this one, it can be your piston, né, that is going up. So when fluid when the fluid is at high pressure and it demands more power, so it will open this valve, so that this fluid will get inside here, and then that the power is going to be supplied outside. So an accumulator is just that it's still the same as what, as a hydraulic press. It's just that it has what, it has a reserve, or a reserve tank that it's storing what you call energy that are on this other side. So thank you. We're looking at the other one. The next chapter will be our hydrostatic force. Um, so don't panic. We are just doing now the basic stuff of what you have to know, and then from there we will continue with question papers. Therefore, we will look at uh, examples. Yeah.